All right, a couple more FRQs. I think I've got 6 more videos to do, including this one. So we're getting there. We're getting there. Set a timer, 25 minutes, yada yada. I found this problem very confusing to look at, and then their notation I thought was terrible because they use A of T for Alice and B of T for Bob, which I think is just horrible. So I am going to very, very briefly talk about derivatives. Derivative of that is V A of T, and then the derivative of that would be A again, but I can't, so I'll go with a capital A of T. Same thing for Bob. His position is going to be B of T, and then we're going to go velocity of Bob of T, and then capital A of Bob of T, which I'm not particularly happy with, but such is life. So my analysis acceleration, looking at a very simple derivative here. I won't lie to you, I'd be surprised to see this on the actual test this year, but okay. So I like to write everything out. And then, like I said, I'm going to do a capital A. And I'm going to find the derivative. And then I'm going to find the acceleration at time 3. Just had a brain cramp. It happens. So we're looking at -6 times 3 plus 24. And big red flag just went off my brain. Watch units. So, hey, it's meters per minute. No, this is acceleration, so it's meters per minute squared. It's hard to slow the brain down to remind it to pay close attention. Use the data from the table. Calculate Bob's acceleration. So they're saying approximate, and that screams out that I'm just going to go on either side here. Pardon me, they want it 3. So either side here. And I'm just doing that average rate of change thing. So big A, little b, 3 is 46, and we always leave our units out here, minus 36 over 4 minus 2. Plus that out, we should get 10 over 2 equals 5. And again, it's acceleration, meters per minute squared. Notice I abbreviate minutes, but not meters, because I don't trust the fact that they're both labeled with an M. And I want to be as clear as possible. Use a right Riemann sum. Approximate total distance that Bob travels. So that's an integral. And for those that know me, I always say we've got to do a mini graph. So 2, 4, 6, 8. Now, they got me on this one. Total distance means absolute value. So this is 2, and I put these dots up there that don't really mean much. I mean, in terms of scale, 34. That was weird. And 46. And 36. And I don't think I even need this one, 3. So right Riemann sum should get us to, oh yeah, they always want you to write this out. So this is B of T, just means Bob's position. And actually we don't want that because it's not position, it's distance traveled. So distance traveled, and I would not abbreviate these. Is the integral from 0 to 8 of the absolute value, the velocity of Bob. Make sure that looks very official. So off we go, equals right Riemann sum, 2 times 2, that's weird, plus 34 times 2, plus 46 times 2, plus 36 times 2. 2, 34, 46, yep. Notice the 2 can be factored out 2 times, and you just add all this up if it helps. In this case, I believe that gets you to 118. Don't forget your units, which I believe they do on their answer key here. 236 meters. Showed you how easy it is to forget those units. Bob gets on the ride. Alice is already on the ride. She's 35 meters in front of him, on the right of him, in the positive direction of him, whatever the heck that means. And blah, blah, blah. From the entry to the ride, find the value of A of 2, which is Alice's position at t equals 2. So now we're actually being exact. So A of t, and I'll put in my 2 later, is the integral from 0 to x, dummy variable, of v Alice of t dt. And they gave me the time at 0, so I have to go on 35. Integrate it, we get negative t to the third plus 12t squared plus 2t from 0 to 2. I guess actually if I had to do it again, I'll just do this, A of 2, that works. Plus 35. Don't have to worry about the 0, blast it out. You should get a total of 79 meters. All right, and that is a position. Position, yeah, not distance. Using a trapezoidal summation, approximate value of b of 6, which is Bob's position at time t equals 6 minutes. Alrighty. 2, 4, 6. I'll need to go all the way this time. And now this is position, so the negative counts. So this is down here at negative 34. At 4 it's at 46. And at 2 it's at 36. And here it's at 3. So let's go with b of 6 is 1/2. They're all 2. First value, 3 plus 2 times 36 plus 2 times 46 plus negative 34. If you need to go back and look at trapezoid rule, that is how we do it. Crank it out, 133 meters. Good problem. A little too vague to make you feel all warm and fuzzy, which I think they'll do. I think they will make something fairly vague where you're going to have to just trust the calculus and read the whole question carefully, distance and position, all that. To an actual real problem, which shouldn't be too bad, but apparently people are going to find this challenging. So part A says, get me f prime of A. I'm going to do this weird little thing where I go ddx because I have to write it like this or else I will not do it right. Put figure on my brain, make it first, equals negative 3, 2x squared minus 7x plus 5 squared, 4x minus 7, f prime of 3, plug it in, and you will get negative 15 over 4. It says find the x-coordinate of each critical point. So that's why we took the derivative in the first place. Notice how important it is to do the derivative correctly. So for B, f prime of x set f prime of x equal to 0. 0 equals negative 3, 4x minus 7, 2x squared minus 7x plus 15 squared, meaning 4x minus 7 has to equal 0, equals 7 fourths. Number line just for me, 7 fourths. Plug in 1 to the derivative, and you get, the bottom's always positive, you get negative negative on top, so positive. Plug in 2, and you get negative. So we're looking at a relative max. So since And again, I would write this all out. Derivative of f of x goes from positive to negative at x equals 7/4. X equals 7/4 is a relative max. Hope I left enough room. Now, partial fractions integration, they do it for us, but they give us this little nonsense with the 5 to infinity, which is kind of a hassle. So I will be lazy, that's funny, lazy integral from 5 to infinity of f of x equals integral of 5 to infinity 2 over 2x minus 5 minus 1 over x minus 1 equals limit as b, and you can use a or b. I usually use a. Don't know why I use b this time. I don't want to write this again, but you should, so I will. 5 to b, 2 over 2x minus 5, 1 over x minus 1, dx equals limit as b goes to infinity ln absolute value 2x minus 5 minus ln absolute value x minus 1 5 to b. Note, always positive can get rid of absolute value. So, let's do a little algebraic stuff. Ln of 2x minus 5 over x minus 1. By the way, when I did the integral, if you're wondering what happened to this 2, chain rule. I don't need these anymore. To b equals ln of 2b minus, I should write it again. I'm trying to be lazy. Tired of writing my limits. Limit b goes to infinity. ln 2b minus 5 over b minus 1 minus ln of 10 minus 5 over 4. Hopefully you remember that equals, as it goes to infinity, the b's cancel out, we go with the bigger. ln of 2 minus ln of 5/4, which is 2 divided by 5/4, which is 2 times 4/5, which is ln of 8/5. That's some good math. And then my personal favorite, I was starting to write this big long book. I said, per part C, and I should write this out, equals 5 to infinity. Three over 2n squared minus 7n plus 3, pardon me, plus 5. Per part C converges by integral test. And I mean, how beautifully designed a problem is that? They have you to the work and then they go there. I was going to compare it to 1 over n squared and say 1 over n squared converges, and this is therefore smaller than that because it's 2n squared, less than or equal to that, so therefore converges. And they would accept that too. They have that in their answer key. But A lot of these are just saying, well, yeah, we just did the test. We're pretty much done. All right. Hopefully we're making progress. Good luck.